which will be a little bit shorter than part one. Part one is slightly longer than anticipated, but never mind. So part one looks at exploring our solar system. So let's begin this. So this is a massive collection of stars, yeah? That is the Milky Way. And inside the Milky Way, this is our galaxy. Okay, so the universe is made of galaxies upon galaxies, and this is our galaxy, and this is the Milky Way. Now, our sun is just one of these stars, okay, just one of these tiny stars. So each galaxy contains about 1 billion stars. So you imagine that when you look up out at our sun, it is just one star in 1 billion stars which make up our galaxy, which makes us feel really, really small. And our star has a load of planets orbiting it, and these stars could possibly have also planets orbiting them. So just gives you kind of a feel about how small we actually are. So Milky Way, billions of stars, our sun is one of them. Now, in the universe, this is a picture from the Hubble telescope showing the billions of galaxies. Now, amongst all of these billion galaxies, yeah, our Milky Way is just one of these. Not sure which one, it could be any of them, but there are literally billions of of galaxies just like our Milky Way. So this is one galaxy, yeah, and there are billions of those. And in the one Milky Way, there are billions of stars like our sun. And just to give you a real feel of how tiny we actually are, and this is our sun right here. Okay, and our sun is our star, and all the planets and the sun make up our solar system. And remember, stars are very hot and they emit light. Okay, these are all the planets in our solar system, and you have to know the order of them. So you've got the sun, you've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. But Pluto isn't actually considered a normal planet anymore. It is considered a dwarf planet. Okay, another picture of them just to show the size difference between Jupiter and Saturn. So we really, really are tiny compared to all the rest of the planets. So you need to know the order, and all it does is, this is how you remember the order of the planets. My very easy method just speeds up naming, and planets I just put in question marks because that's Pluto. So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. So yeah, so what we need to know, what else is in our solar system. So there are comets. Now, comets are made of ice and dust, and you need to know the difference in comets and meteors. And meteors are just small rocks and grains of dust. Black holes are also in our solar system, and they are formed when big massive stars collapse, and gravity in them is so strong that not even light can escape them. Okay, and that is a picture. Well, we don't really know what a black hole looks like, but this is kind of an artist's representation of what a black hole might look like, and you can see that it's pretty much very, very dark because light, like I said, that light can't even get past it because the gravity is so strong. Now, light years. Now, light travels at 300 million meters per second. Now, one light year tells you about how much distance that light can actually travel in 1 year. And that is a massive amount. If you imagine that light travels at 300 million meters per second, that is 1 light year. The distance of 1 light year is actually 9.5 million kilometers. Now, that is massive because the distance between one star and another star is huge. So we can't just measure it in normal distance amounts. We measure it in something called light years, and that is 1 light year. Okay. Now, manned spacecrafts. We can send manned spacecrafts, and we've pretty much just been to the moon. I say that, but it's a massive feat for mankind actually traveling to the moon. But what kind of things do you need to consider for manned spacecrafts? You need to consider that we need to have enough oxygen. You need to think that we need to have enough water. We need to have food. We get muscle wastage. What I mean by muscle wastage is because we have gravity on this planet, and our muscles move against the force of gravity, but in space there isn't very much gravity at all. You only get gravity when you're orbiting near a planet, and so the muscles, because they're not used, you get muscle wastage. And heat, it is very cold in space. Okay, you get cosmic rays. Normally our ozone protects us against harmful UV rays, but when you're in space you get a lot of radiation, And so that is also something you have to consider. And obviously, when you're walking around on the moon, as you do, you have to have a spacesuit. Okay. Now, instead of sending manned, you can also send unmanned spacecrafts, and basically like probes. And what we do is we send out probes, and when we do send out the probes, we put out this symbol over here. Yeah, so when the probes get sent out, they send this image, which tells us a little bit about what humans are like. So you've got male, female there, and it talks about where we are in terms of the solar system, etc. And those are all the planets, and that points towards Earth. Okay, so why do we send out the probes to space? Well, what can we find out? Well, we know a little bit. The probes can measure the temperature of where they get sent out. They can measure how strong the gravity is, gravitational forces. They can measure the irradiation, the magnetic fields, what kind of atmosphere the thing has. So we've actually sent probes all the way out throughout the solar system just to measure out these things, because we can't get manned spacecrafts to go all the way out that far because of the lack of food, the oxygen, and everything else. Okay, so what's in our universe? Galaxies, stars, black hole, planets, comets, and meteors. Okay, and we talked about light years, we talked about those. Right, threats to Earth. Okay, so where did the moon come from? That is the moon, and the moon is our satellite, which means that it orbits Earth. And the moon was formed when a planet, which is a very similar size to Mars, collided with Earth. The two cores of the planet formed the core of the Earth. Okay, a little bit like this. So when the planets collided, that's what happened, and they collided, and all the dust left over formed the moon. Because they might ask you a question about how the moon was actually formed. So another planet collided with Earth, and all the dust left over formed the moon. Okay, now evidence from the formation of the moon. Well, the Earth has a very large iron core, but the moon has a much smaller one. Moon rocks and the crust are very similar to the ones found on Earth. Okay, this is the asteroid belt, and the asteroids are smaller than planets, and they're forms of rocks, and they're left over from the formation of the solar system. Most of the asteroid belt is found between Mars and Jupiter. Now, if we go back and have a look at Mars and Jupiter, yeah, we can actually see, this is going back a bit further than I wanted, between Mars and Jupiter. So right there, you've got the asteroid belt going over, which is loads of meteors, etc. Okay, let's go back to where we were, which is right here. Okay, so dangers, yeah, so all these asteroids are basically bombarding Earth. Now, most of them are small enough, and they actually burn up before they actually get to the Earth. But scientists are giving out warnings that massive asteroids could come towards us and send out killer strikes by the year 2017. And so that's what they're warning us about. And if an asteroid does collide with us, this is from the film, I can't remember what this film is from. I think it was just called Asteroid? I can't remember. But anyway, and if it does collide with us, if an asteroid does hit us, this is basically what can happen. Hot rocks would rain down. Fires would become widespread. Tsunamis, which is basically big, massive walls of water, would come coming down. Clouds of dust will form, and so sunlight wouldn't be able to get towards us, and the temperature could fall down so much that 70% of all species on Earth could die. So this is a real kind of Armageddon kind of thing. And it's something to be worried about. Okay, so has an asteroid hit us before? Yes, we believe it has. And that is a massive crater formed by one of the asteroids actually colliding with us. And they say that the asteroid colliding with us is one of the reasons that dinosaurs actually became extinct. Okay, so that is one extinction theory, that one asteroid, giant asteroid collided with Earth and killed most of the dinosaurs. So NEO, not Neo from the Matrix. NEOs actually stand for near-Earth objects, and they're asteroids that could potentially collide with Earth. Okay, now comets, you have to know a little bit about comets, and comets are made out of rock and ice. They orbit the sun, but unlike planets, have something called an elliptical orbit. Now, what that means is, elliptical means egg-shaped. They speed up when they're near the sun because the gravity is stronger there, and when they are away, when they're near the sun, because all the ice is melting, they leave behind a little tail. And so this is Halley's Comet, and as you can see, this is the egg-shaped orbit that it has, and we say it's an elliptical orbit. Again, you guys have to know the term elliptical to describe comets over there. and this is why they form a tail. So this is in the elliptical orbit that a comet might have. As it gets close to the sun where the ice is melting, that's when it has a tail. But further away from the sun, it doesn't have a tail because the ice isn't melting. Okay, now NASA actually have a website dedicated for near-Earth objects, and they report on all of the near misses that happened. Like, for example, this one is saying that there was one on the 25th of February. It's not very long ago at all. So, I've repeated this bit of the thingy. So, Big Bang Theory. So, there are many models to explain the universe around us. So, it's not a very easy thing, as we can't visit the universe. So, we're going to learn the two main theories about our solar system and where they came from. One of them came from Claudius Ptolemus, okay, or the otherwise known as Ptolemy. And this is Ptolemy right here. And what he basically said is he believed in the geocentric model of the universe. And what he said was that the sun was right in the middle, the earth was in the middle of everything, and all the planets and the sun and the moon orbited around the earth, which is silly really, but what did we know? We didn't even have telescopes back then. So geo means earth, and centric means center, meaning that the earth was actually at the center. And he said that the earth was at the center of the universe, just like this. This is the model that he drew, and he said that the earth is bang in the middle, and everything, including the sun, orbits around the earth. Okay? And so that was the geocentric model. Geo meaning earth, centric meaning at the center. Okay? Now, this was a very clever chap called Copernicus. Now, Copernicus said that actually, you know what, I don't think that's it at all. I think it's the heliocentric model. Now, the word helio means the sun, and as you know, the word centric meaning center. And what he said was that the sun is at the center of the earth. Okay, but his book was banned by the Catholic Church. Okay, why? Because they wanted everyone to believe that the earth was at the center, and because obviously God made the earth and made everything revolve around the earth. And so what you're doing is you're going against the word of God. Okay, so he came up with a different model, and he came up with the idea that the sun was at the middle, which is the way it is, and all the other planets orbited them. Okay, and it was this chap over here that actually added a little bit of weight behind his theory, because what he did is he used telescopes and actually looked at all the moons, etc., and the orbits of the other planets. And so Galileo was that chap's name, and he used telescopes to back up Copernicus. And so Galileo heard about the invention of the telescope in Holland, and he had never seen an example, but he made a much better version because he was incredibly smart. And so he looked at valleys on the surface of the moon, he looked at sunspots, he looked at the Jupiter and the phases of Venus, and he worked out how it was. But basically, what the problem was is he was he was locked away because the Vatican, which is the Roman Church, said that you're again going against the word of God. Okay, so Big Bang Theory. Now, it's not the television program, but that's where the name comes from. The Big Bang Theory states how the universe was created in the first place. Now, what he's saying is, well, what scientists are saying is that the universe was created 15 billion years ago at a single point, with temperatures of, wait for it, 1,000 million degrees. That is hot. Okay? The universe cooled after 1/10 of a millionth of a second to 1 million degrees. So not as hot, but still pretty hot. So there was a big bang, hot temperature, then it cooled down by less than 1/10 of a second, and then that made the universe. So what basically they are saying is that the universe is expanding, and that's what these balloons are signifying. That you imagine that all the galaxies, etc., are moving away from each other because they're saying that they believe that the universe continues to expand. Okay, so the universe is expanding, which means that all the galaxies are moving away from each other. Okay, these are all the galaxies, just as a reminder to how big the universe is. And remember, in each galaxy there are 1 billion stars, and there are 1 billion galaxies, so it's massive. It really is massive. This shows the constellations. So we've got the stars in the sky, and they stay in pretty much the same place. And so people have come up with all the constellations, with some of the most famous ones being the Seven Sisters, Orion. You've got the Big Dipper, the plough, etc. Okay, now you need to know about what happens when stars die, because they do die. And when a star has used up all of its hydrogen, it begins to die. Because that's what stars do. They get hydrogen and they combine the hydrogen to make helium, and that makes up a star. And that gives off energy through nuclear fusion. Okay, and so this is what's going to happen to our sun when it runs out of hydrogen. It is going to expand and it's going to turn into a red giant, and it's going to swallow the Earth. You can see that. That's the Earth's orbit. That's how big it's going to get. Okay, now you can also get planetary nebulas, okay, which is basically a gas, a big cloud of dust and gas, and you can get a white dwarf, and that's the sun right now. And when the sun dies in 6 billion years' time, it will turn from a red giant and then into something called a white dwarf. Okay, now massive stars, because they're so big that it doesn't take them very long before they use up all their hydrogen, like a few million years. And what happens is the core contracts and the outer parts become a red supergiant. The center collapses and the whole star explodes. And when it does explode, it makes a supernova. Okay, now this is a lot of information, and definitely go back and revisit all this again. Okay, so this is the planetary nebula, and this is a neutron star. So really big, massive stars, eventually when they die, they won't turn into a white dwarf, they will turn into a neutron star. Now here's this for an interesting fact, that 1 teaspoon of a neutron star weighs 1 million tons. That's 1 teaspoon weighing 1 million tons. Now that's heavy. So if a star is really big, it forms a black hole. Now remember about black holes, and not even light can escape a black hole. And we know if we see an area where it's dark, that's where a black hole is. So this is a life cycle of a star, and guys, you have to know this. So you have a planetary nebula over here, a stellar nebula, which is basically a load of gas. And when the gas builds up so much that the gravity begins to pull it in. And if you've got an average size star like our sun, when it dies and uses up all its hydrogen, turns into a red giant, then turns into a planetary nebula, then it makes a white dwarf. But if you've got a massive star, then it's going to make a star, then it's going to turn into a red supergiant, which is different from a red giant, then into a supernova, and then either a black hole or a neutron star. Guys, have a look through this, because you need to know the life cycle of a star and how it actually works. Okay? And that was everything that I wanted to go through, and that is P2 done. Well done, guys, for making it your way all the way throughout those videos. I hope that's been useful for you. And guys, please go through it again, pause it, try and understand it, maybe even take down some notes. But everything that I've been through is all the things that you have to know. Okay, well done and good luck. Bye-bye.